Okay, in the second part of lecture number 2, we are going to discuss about mixtures and the pure substances. So let me go back into the slideshow mode. Give me 1 second. Okay, so we have discussed all these things. Okay. Okay, so the matter is made of mixtures or the pure substances. Now these mixtures can be homogeneous mixtures or they can be heterogeneous. Now the example of homogeneous is like solutions. Like solution is something like if you take a glass of water and add salt to it, dissolve it, it's a solution. So which means the concentration of the salt in that water is same everywhere. So that's the solution. Heterogeneous is where the concentration of your solutes is different, like the example is sand. Now on the other hand, the pure substances, they can be element or they can be compounds. So elements, we just discussed what are elements and what are compounds. So elements, you study different kinds of elements, and these elements, when they combine, different elements combine with each other, they form the compounds. So when they combine in some specific ratios. So we discussed why these elements they form compounds, why they have to react with each other, or why they have to bond with each other. So that bonding is because they have to satisfy the octet rule, which means they have to have their valence shell completely filled, because only then in that situation they are stable, and that is why they form the compounds. So mixture composition varies from sample to sample, can be separated into components by physical means. Homogeneous mixture, example I gave you the solution, which means the homogeneous mixture, same composition throughout a given sample, does not vary in composition from one region to another. So the example is you either take a glass of water, add either salt or sugar and dissolve it, everywhere the composition is going to be the same. So that is a homogeneous mixture. Now heterogeneous is within a sample, regions have different properties. Like if you take this sand, so in the sand the composition is going to be different in the different regions, so that's your heterogeneous. Or the other examples are coal and wood. Now pure substances, we just discussed what are elements, what are compounds, and why do these elements they react. Okay, so this is the table showing you some of the important elements which make the crust of the earth, and these involve oxygen, silicon, aluminium, iron, calcium, sodium, potassium, and magnesium. And we also discussed that atom is the smallest unit of any element. So element is made of atoms. So in one element all the atoms are going to be same, but if you compare the atoms of one element with the another element, they're going to be different. But within one element also there's a possibility to have different atoms. So the different atoms of the same element which differ by number of neutrons, they're called isotopes. So which means isotopes are possible. Okay, those isotopes are different atoms of the same element. We talked about we give you example of hydrogen. So similarly in carbon also different isotopes they exist. And we also studied what is a molecule. When two atoms of the same element they bond, they form a molecule, and that's the main difference between molecule and a things. So now let's see what is a physical change and what is a chemical change. Now physical change is the one which does not result in change of identity of the matter. For example, you boil or melt or condense something, that does not change the identity of matter. So boiling, melting or condensing is a kind of a physical change. But what is the chemical change? So physical change is the one which does not result in the change of identity of the matter. So chemical change is alters the identity of matter, producing new substances with different properties. So when you cook food, something different is formed, right? Or if there is burning, so if you take wood and you burn it, it's going to be converted into ashes, right? And a lot of energy is going to be going in the air in the form of heat. So all these things which alter the identity of matter, that is called the chemical change and something new is formed. Okay, so in the chemical change involves chemical reactions. Now here is example of a very typical chemical reaction. This is photosynthesis. Okay, what do these plants do? These plants take the carbon dioxide from the environment and water from the soil, and with the help of solar energy, sun's energy, they make carbohydrates, okay, which is a food for them and also food for us, and they also give us oxygen. So this is a chemical reaction. This is a chemical change in which you start something and you form something different. So the plants, they start with carbon dioxide and water, and they make carbohydrates. Now this is example of cellular respiration. So as you all know, we eat food, right? So we eat food to get energy, and that energy we use to do various activities. Now how that food gives us energy? So inside our body, so we are basically made of cells. In every cell we have mitochondria. In that's called the powerhouse of the cell. So there this food is burnt. Basically it's actually not burning, or we can say in scientific terms the food is oxidized and energy is extracted. Okay, so so whatever food you have eaten, it's going to be combined with oxygen, and energy will be extracted, and carbon dioxide and water is going to be produced. So this is another example of a chemical reaction. So in a chemical reaction, so remember that something new is going to be formed. Okay, so chemical reaction. So to write a chemical reaction, we have to write a chemical equation. Now what is a chemical equation? So chemical reactions are basically depicted by these chemical equations. So in a chemical equation, we have reactants, we have products. So reactants are usually on the left side and products on the right side. Okay, an arrow indicates a change. So here, like, reactants are the ones which are going to react, and they're going to form products, something new. Okay, you start and you end with products. So this is the arrow. So this arrow is showing you're starting with the reactants, you are making products. So reactants are usually on the left side and products are on the right side. So use chemical symbol and formulas for each reactant and product. So in science, when we write things, we use symbols and formulas for the reactants and the products. And correct equation should be balanced. So which means that, so this is the reactant side, this is the product side. So how many carbons on this side? The same number of carbons should be on this side. So how many oxygens on this side? Same number of oxygens should be on this side. Same number of, so whatever hydrogens are on this side, the number of hydrogens should be on this side. If that does not happen, that equation is called unbalanced. So correct equation should be balanced. It should obey law of conservation of mass. All elements on reactant side, all elements on reactant side also on the product side. So which means whatever elements, so the way I just said, so if we have, like, on this side we have 1 carbon, we should have 1 carbon on this side, so that's fine. So we have 4 hydrogens on this side, we have only 2 hydrogens on this side. We have 2 oxygens on this side, we have 3 oxygens on this side. So this is unbalanced. So the elements on the reactant side is not equal to the elements on the product side. So equal number of atoms of each element on reactant side as on the product side. So the equation should be balanced. So this was unbalanced equation. Sorry. Okay. So this is balanced equation. So this is unbalanced, this is balanced. So you can see this is your methane gas reacting with oxygen and forming carbon dioxide and water. So in this equation it's unbalanced, but in this it is balanced. So you can see 1 carbon, 1 carbon. So how many oxygens? 4. 2 here, 2 here, 4. That's fine. How many hydrogens? 4. So here on this side of 4, on this side also 4. So this is a balanced equation. So these are different types of chemical reactions we need to know. First is oxidation and reduction reaction, or we also call redox reactions. So these are the kind of reactions in which electrons are transformed from one atom to another. So the reaction in which the transfer of electrons is involved, redox reaction or oxidation reactions. Now what are combination reactions? Combination reactions are reactions in which synthesis takes place, okay, in which synthesis in which two or more substances combine to form a single compound. So in which uh, in which one or more substances they're going to combine, okay, to form another compound. So that is your combination of the synthesis reaction. Decomposition reactions, compound broken down into elements, simpler compounds or both. So it's opposite of combination. So decomposition is when your compound is going to be breaking up. That is a decomposition. Replacement reactions, atom or polyatomic ion is replaced by a different atom or a polyatomic ion. So here is example like this is Fe is iron plus copper sulfate. So this is your reaction basically between iron and copper sulfate. You can see here that this is a compound formed by copper and sulfate. Now in this reaction, this copper is being replaced by iron. So it is now becoming copper and iron sulfate. So this is kind of a replacement reaction. So copper is being replaced by iron. So this is a replacement reaction. The last ones are ion exchange reactions. So in these kind of reactions, there is going to be exchange of ions. Ions of one compound interact with ions of another to form either a precipitate, gas or water. So see this reaction. Sodium hydroxide is reacting with HCl, which is your hydrochloric acid. So sodium hydroxide is reacting with HCl, and in this reaction what's going to happen? Exchange of ions is going to take place. So here hydrogen is bonded with chlorine. So and here sodium is bonded with hydroxide. So this chloride is going to be exchanged for hydroxide. So chloride is going to bond with sodium. It's going to form sodium chloride, and hydroxide is going to combine with hydrogen, and that's going to form water. So this is example of exchange reactions where the ions are getting exchanged. So these are the different kinds of chemical reactions you need to know. So that finishes our lecture, and that's all you need to know. I hope everything is clear. If you guys have any problem, you are always welcome to send me email or call me. Okay, bye.